Welcome to Astronomy Daily. I'm excited to bring you another packed episode of Space and Astronomy news. We've got some incredible stories lined up for you today that showcase humanity's ongoing exploration of the cosmos. We'll start with an update on NASA's Parker Solar Probe's remarkable Christmas Eve achievement, as it made its closest approach ever to our sun, while becoming the fastest human-made object in history. Then we'll explore China's ambitious plans for new rocket launches in 2025, which could reshape their space capabilities. We'll also dive into some fascinating research about icy worlds like Europa, examine a recent software glitch that affected satellite communications, and look ahead to some spectacular celestial events coming our way. The universe keeps surprising us with new discoveries, and I can't wait to share them all with you. Let's get into today's news. On Christmas Eve, NASA's Parker Solar Probe achieved an extraordinary feat, skimming closer to the sun than any human-made object has ever ventured. At precisely 6:53 a.m. Eastern Time on December 24th, the spacecraft passed within just 6.1 million kilometers of the sun's surface, shattering its own previous record of 7.26 million kilometers set earlier in 2023. But that wasn't the only record broken that day. During its closest approach, the probe became the fastest object ever created by humans, reaching a mind-boggling speed of 692,000 kilometers per hour. To put that incredible velocity into perspective, at that speed you could travel from Philadelphia to Washington, D.C. in about 1 second. This remarkable achievement marks the culmination of 6 years in space for the Parker Solar Probe. Since its launch in 2018, the spacecraft has been on a complex journey to study the sun's outer atmosphere, or corona, from the inside. Due to the sun's powerful gravitational pull, the probe couldn't simply fly straight to its destination. Instead, it has been performing an intricate orbital dance, using Venus's gravity to gradually adjust its path closer to the sun through 21 increasingly narrow flybys. The mission reached a crucial milestone on November 6th, when the final Venus flyby positioned the probe into its optimal orbit. This carefully calculated position allows the spacecraft to study the sun's processes up close while remaining just far enough away to avoid destruction. During its closest approach, the probe was completely out of contact with Earth for about a week. The tension finally broke just before midnight on December 27th, when scientists received a beacon signal confirming the spacecraft had survived its daring encounter. 3 days later, on New Year's Day, more detailed data arrived, showing the probe was healthy and had successfully collected scientific measurements during its record-breaking flyby. Mission controllers must have breathed a huge sigh of relief. The probe will maintain this new orbit for at least 9 months, with 2 more equally close passes planned for March and June, before its primary mission concludes in September 2025. These repeated close encounters promise to reveal unprecedented details about our star's behavior and help us better understand the forces that shape our solar system. Next up today, Eutelsat recently reported a significant disruption to their OneWeb satellite network that left users without service for 2 days. The outage, which began on December 31st, was traced back to a rather familiar culprit in the computing world, a leap year software bug in their ground segment systems. The timing couldn't have been more ironic, as the system failed to properly account for 2024 being a leap year. Services were only partially restored after 36 hours, with full functionality returning shortly thereafter. This incident highlights just how complex modern satellite networks are and how even seemingly simple oversights can have far-reaching consequences. What makes this particularly noteworthy is that OneWeb had just recently achieved the capability for worldwide coverage in 2023. The company has been steadily working to expand its services across the Americas, Europe, and Asia, with plans to launch full services for government and enterprise customers, including aviation, this spring. The good news is that Eutelsat's multi-orbit capabilities should provide better network resilience in the future. The company operates both the OneWeb constellation in low Earth orbit and a fleet of 35 geostationary satellites. This dual-system approach is part of their strategy to compete with industry leader Starlink, allowing them to supplement OneWeb services with geostationary capacity in high-demand areas. Looking ahead, Eutelsat isn't letting this setback slow their momentum. They've already ordered 100 new OneWeb satellites from Airbus Defence and Space to ensure the constellation remains robust as the current satellites reach the end of their design lives in 2027 and 2028. Next, we head on over to a country that's fast becoming a major space force to be reckoned with. China is gearing up for an exciting year in space, with 2025 set to see the debut of several new rockets from both state-owned enterprises and commercial companies. These new launchers represent a significant leap forward in China's space capabilities, particularly in the realm of reusable technology. Leading the charge is the Long March 8A, an upgraded version of the existing Long March 8 rocket. This new variant features a more powerful second stage that boosts its payload capacity to 7,000 kilograms to sun-synchronous orbit. What's particularly interesting is that they're incorporating a larger 5.2-meter diameter payload fairing, giving them more flexibility for future missions. Another notable development is the Long March 12A, which is taking a page from SpaceX's playbook by implementing vertical takeoff and vertical landing capabilities. This marks China's first serious venture into reusable rocket technology at the state level. The commercial sector is equally ambitious. Landspace is preparing their Zhuke 3 rocket, a massive stainless steel launcher that will stand 76 meters tall. In expendable configuration, it will be capable of lifting 21,000 kilograms to low Earth orbit, or 18,300 kilograms when recovering the first stage downrange. This impressive capability puts it in direct competition with some of the most powerful rockets currently operating. We're also seeing several other commercial players entering the field. Galactic Energy is developing both the Pallas 1, designed for eventual reusability, and the upgraded Series 2 solid rocket. CAS Space, a spin-off from the Chinese Academy of Sciences, is working on their Kinetica 2 rocket, which aims to serve China's growing commercial space sector. These new rockets aren't just about showing technological prowess, they serve a practical purpose. They'll be competing for contracts to launch satellites for China's ambitious mega constellation projects, space station cargo missions, and commercial payloads. This expansion in launch capabilities is essential for China's growing space program and could potentially attract international customers, though geopolitical challenges remain a consideration. The influx of new launch vehicles, particularly those incorporating reusability, signals China's commitment to developing a robust and competitive space industry. While some of these companies will be competing for limited domestic contracts, the end result will likely be a more capable and cost-effective space launch sector for China. Exciting new research has emerged that could revolutionize our understanding of icy ocean worlds like Jupiter's moon Europa. Scientists have introduced a novel concept called the synotectic, which helps us understand how liquid water can remain stable under extreme conditions on these distant worlds. The research published in Nature Communications comes from a fascinating collaboration between Dr. Matt Powell-Palm from Texas, A&M University, and planetary scientist Dr. Baptiste Journeau from the University of Washington. Their work couldn't be more timely, as NASA's Europa Clipper mission prepares for its journey to Jupiter's mysterious ice-covered moon. But what exactly is the synotectic? It's essentially the absolute lowest temperature at which liquid water can remain stable under different pressures and concentrations. Think of it as a thermodynamic boundary that helps us determine where liquid water might exist on these icy moons, even under seemingly impossible conditions. What makes this research particularly intriguing is how it bridges two very different fields. Powell-Palm's expertise in cryobiology, originally focused on medical applications like organ preservation, combines with Journeau's knowledge of planetary science to create a powerful new framework for understanding these alien environments. With NASA's Europa Clipper mission, representing the largest planetary exploration mission ever launched, this research couldn't come at a better time. The mission will help us understand how deep Europa's ocean is and what it's made of. When combined with these new laboratory findings about liquid stability, we'll be able to better assess just how habitable these cold, deep oceans might be. The implications are profound. This research doesn't just help us understand Europa, it could apply to numerous other icy worlds throughout our solar system. As we continue to search for potential habitats for life beyond Earth, understanding these fundamental properties of water under extreme conditions becomes increasingly crucial. This work represents another step forward in our quest to understand these fascinating worlds and their potential to harbor life, demonstrating how breakthroughs in seemingly unrelated fields can come together to unlock the mysteries of our cosmic neighborhood. Now, something to look forward to. Space enthusiasts and skywatchers are in for a treat in 2025, with 4 spectacular eclipses on the calendar. While we won't see any total solar eclipses this year, we'll be treated to 2 total lunar eclipses, something we haven't experienced since 2022. The first major event comes on March 14th with a total lunar eclipse that's perfectly timed for viewers across North and South America. If you're in the contiguous United States, Mexico, or Canada, you'll be able to witness the entire show, from the first shadow crossing the moon's face to the last. During totality, which lasts for 66 minutes, keep an eye on the moon's northern edge. It should appear slightly brighter than the rest of the shadowed disk. 2 weeks later, on March 29th, we'll see the year's first partial solar eclipse. While Europe and Northwest Africa will get a good view, the best location will actually be in Quebec, near Hudson Bay, where observers can witness up to 93% of the sun's disk covered at sunrise. September brings our second pair of eclipses, starting with another total lunar eclipse on the 7th. This one favors the Eastern Hemisphere, making it a perfect evening show for Europe and Africa, while Asia and Australia will catch it in the early morning hours of September 8th. The eclipse's totality will last an impressive 82 minutes. The year's final eclipse occurs on September 21st, with a partial solar eclipse that will be primarily visible from the South Pacific and Southern Oceans. New Zealand will get the best populated area view, with up to 73% of the sun's disk covered from the country's southern regions. While this might seem like a relatively quiet year for eclipses, it's setting us up for some truly spectacular events in 2026, including a total solar eclipse visible from Spain in August, something eclipse chasers are already eagerly anticipating. That wraps up today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space and astronomy. If you'd like to stay up to date with all the latest space news, head over to astronomydaily.io, where our newsfeed is constantly updating with the freshest stories from across the cosmos. You can also listen to all our previous episodes there. Don't forget to follow us on social media. You can find us as Astro Daily Pod on Facebook, X, Tumblr, YouTube Music, and TikTok. Until next time, keep looking up and stay curious about the wonders above us.